Guys, let's do the packet work lab and do some packet capture. In last video, we explained about the what are the packet walk interview question and answer. So in this video, I'll be explaining you the lab setup so that I can do a packet capture and explain you what happens. Okay, let's quickly do it. So I'm gonna log into this router. And see, this question answer is in the lab that what we are trying to do achieve is basically to capture the packet transversing from the source to the destination. Okay, the source will be here and destination will be here. And what are all the the parameters that changes when it transfer from one router to another router, that we will do a packet capture, then we will explain it to you so that it will be easy for you to understand. Also, when you do an answer, you can explain to your interviewer in a way that you already tested and this is how it works. So he at least you can convince him, right, with all your answers with the justification. Okay, let's do it quickly. So let me check routing table. I already pre-configured the OSPF and everything from source to destination. So here you can see that my R3 loopback IP is 3.0.0.1. I based on the the R1, R2, R6 and R4. Based on this, my loopbacks also configured with respect to the router number. So the destination router will be 4.0.0.1. I'm just clicking it and opening a session here. Yes. So I can check the interface, show IP interface brief. Okay, you can see my loopback is 4.0.0.1. Show IP route 4.0.0.1. It is learned via OSPF with route metric of 41. Okay, so now what I'm going to, I'm initiated traffic from this R3 to R4 and do a packet capture in between the routers in the network so that we can do an analysis and comparison. So first let's do me a capture here on the interface Ethernet 0/1, capture Ethernet 0/1. This is on the first of interface. Okay, then I will do a capture here. I just want to show you guys what all the the packet changes happens so that you will be able to analyze it, and it will, you won't forget it actually. When you do this kind of analysis, you won't forget actually. That is the main thing that I want to do it. Okay, I'm going to initiate a packet ping 4.0. Okay, let's copy this 4.0.0.1. So then I will ping with source 3.0.0.1 and count, repeat. I'll just send a one packet so that I can do a filter. Okay, the ping is success. Let's do the packet capture. Let's filter with ICMP here and all the packet capture. Okay, now we have kept, like we have seen like the source and destination packet, right? Let's see like what the source as a center request from here and what all that happens. Okay, so here, so you see the source IP and destination IP is 3.0.0.1 and 4.0.0.1, which I explained you about the TOS bit. It's CS0. So by default, we don't have any explicit configuration. So this will remain unchanged throughout the network. Okay. Then next, if we go to the MAC address, which I told you guys, Here the source MAC and destination MAC. Okay, make a note of it. This is the first hop router that we are doing it. And one more thing I told you about the fragmentation. Currently, the fragment offset 0. In case if it is a fragment offset 1, means the fragmentation is happening. So currently there is no fragmentation as the link MTU is same on all the router. Also, we have more fragment and related to fragment flags. So this I will explain in a separate video. Currently note there is a default configuration and no fragmentation has been set. So this value will also remain constant, will not change. And you can see this TTL. So TTL, whenever it passes from one router to the next router, this TTL value is supposed to change. Okay. So you know, make a note, it's a 255. Okay. Let me check this router R1. Show IP router, right? So it is learning via show interface Ethernet 0/1. Okay. When you see this, what is the MAC address here? It is AB3010 ending with 3010. Here you can see the source MAC is 3010 and the destination MAC is 1010. Okay, if I execute show ARP, here you can see 1010 is the next hop router which is connected to R3. This is R1. So let me quickly log in and check the interface on Ethernet 0/1. So here you can see this is the MAC address. So the source MAC address is R3 MAC address and the destination MAC address is R1. That's what that we see from this packet capture. Let's move on to the next packet capture. Here the echo request. Okay, we'll find the echo request on this packet capture. Here you can see. So this is captured here on which router? So this we have captured on this router. So let's see like what is the source MAC and destination MAC on this packet. The source MAC would be this interface and destination MAC will be this interface. So let's find out that. Also the TTL value which I want to tell you, right? So let me open the okay, first let's open the MAC address. Okay, let's open the IP. Let's see how many hop. It says that 253, right? So the TTL value is getting deducted. Okay, the TTL value is getting deducted. The source and destination MAC is same. Okay, sorry, source and destination IP will be same. There won't be any change, and that there is no change in the fragmentation. There is no change in the QoS CSO. Okay, so we'll check the MAC address here. Here you can see the MAC address is changed in the previous packet, which that I want to compare this. Okay, if you see this is the first packet that we checked, right? So here you can see the source and destination MAC here, and here you can see the source and destination MAC. Both are different. So in each and every hop, the source and destination MAC will be changing till it reaches the destination. But in case of source IP and destination IP, this will not change. This is what the interviewer will looking at you. They'll ask you, they'll try to confuse you, asking, okay, are you sure that the source IP will change or the destination IP, destination MAC will change? So what will change? So they try to test you. So you can say it's like practically we tested it. So only the source MAC and destination MAC will change. And what happens whenever it travels from one hop to another hop, it changes the TTL value also. Here the TTL value also get changed at each and every hop. Okay. Then what are the other things that you may see is the fragmentation is correct, the QoS bit is correct. Okay, remaining all is same. Let's check the final capture that we have done. This is the request. Here you can see which is exiting this router. Here we have done the capture on Ethernet 0/2 here. So let's see what it says on the request packet. Okay, here you can see the source IP, destination IP will not change. Only the source MAC and destination MAC will change on each and every hop on the router. The QoS, it's a default configuration. There is no change here. The fragmentation, there is no change in the fragmentation. And source IP and destination IP will be different, will be same. And you can see that every hop, the TTL will get deducted and then send it to the next router. When it received, it was 253. And now it is 252 when it's sending out. Okay, so this is the packet capture. Now you guys have some good understanding about the packet walk, what happens in the IP header and Ethernet header when it travels from one router to the next router, and throughout the part the same process will happen. So this is how you need to explain to your interviewer. And one more thing that I want to do some addition. So here you can see, so when I do a packet capture here, here you can see in the capture, right? I see only the reply here on this interface. And when I do a packet capture, like when I did a packet capture here, I see only the request. Why it is happening is because here you can see I have two links. What I did, the costing, right? Here the costing is same, so I'm doing just kind of load balancing. So in this case, the one packet will go via this, and another packet can come go via this also. So that's the reason one end I see the request, and another end I see the reply via this router. So it's kind of load balancing actually. So in order to do a packet capture, you need to do capture on all these routers, so that you will be able to do a packet capture in the production environment also. When you do go for a work, so it is not like it will always be a straight line where you can do a packet capture and work on it easily. There will be a complex architecture where you need to understand the architecture so that you can do the proper troubleshooting based on the network.